Hi guys, I'm just logging on quickly to explain a simple concept to you that many of you might have already picked up on, but it's a simple relationship between three things: simple interest, arithmetic sequences, and linear relations. And I'm gonna quickly explain how these things relate to each other. And I would read this paragraph to you, but I think it's much easier for me to show you what the relationship is rather than to explain it to you in words. So let's just quickly jump to this, and I mean, sorry, not this. Let's quickly jump to our writing page here, and I'll explain to you exactly how these things relate. So first, let's look at the relationship between simple interest and arithmetic sequence. So I'll show you the relationship and I'll do it, and I want to see if you guys can just figure it out from what I'm doing, and then at the end I'll also like verbally explain it to you as well. So first off, we have let's take arithmetic sequences, and in an arithmetic sequence we have a set of numbers that are increased or decreased by, or let's say a set of numbers that have a constant added to them. And even more specifically, we can say an arithmetic sequence is where a set of numbers where each prior term is has a constant added to it to achieve or gain the successive term. So for example, I've already explained this to you guys in my prior videos about arithmetic sequence. So 2, 4, 6, I won't spend too much time on it. So 2, 4, 6, 8, 2 you add 2 to get 4, 4 you add 2 to get 6, and 2 you add 6 to 6 you add 2 in order to find 8 or get 8. So pretty much you add a constant to the prior term to get the successive term. Simple enough. Alright, so now let's generalize this formula for all the terms, right? So let's generalize this set of numbers actually. So in this case, we have an initial value. We know a represents initial value, so and that initial value is 2, right? And then because 2 is the first number, and then we have a d value. D is the constant, so the constant in this case is 2 because that's what you're adding. Alright, so now let's generalize this formula. So if I mean not this formula, this set of numbers. So the first thing we have is a. 2 is a, right? And the second thing we have is is 4. 4 is what? It is a plus 2, so a plus d. This is kind of a little complicated example, or not complicated, but it kind of construes the topic or convolutes it because it's the a and d values are the same, but you'll still get the general concept. And then what do you have for 6? 6 you have a, so that's a2, and then what do you add to 2? You add 4. 4 is what? 4 is 2d, right? And then and finally you have 8, which you can write as, let's get some more room here. You can write as a plus 3d. Simple enough. All right, now let's take a look at All right, so this is an arithmetic sequence. It's the general set for an arithmetic sequence. Now let's take a look at simple interest quickly to see, and then I'll see if you guys understand it. So simple interest, in simple interest you have a p-value, any p-value, right? And you have then a ratio, not a ratio, an interest rate. For example, that could be like 3%, right? And let's say it's compounded yearly. Let's not confuse it with anything. And so pretty much this p-value is increased by 3% every year, and it's that same p-value, the original basic principle, not like compound interest. So so for this p-value now, we would pretty much rate. We know the general formula for simple interest is what? A is equal to p plus p r t, right? And I've already explained this to you in a prior video, so I'm not going to spend too much time on it, but just for general understanding, p is there because you know, you have the base principle that has to be added on to whatever your amount is, and then you're adding onto that prt. By pr, pr is the the percentage of the principal that you're adding. So if it's 3%, then it would be like 0.03 p, right? And that is how much you're adding to p, because you're increasing p by 0.03% of p. And then finally you have a t value. What does t mean? Sorry, control Z. T is the time. And what do we mean by time? How many times has the interest been calculated? So we always do it in years, right? We do it in years, sorry. And then so for this t we would just simply do that. Like for example, it's by t because it's how many times are you gonna add on the 0.03% of principal? I know it's getting a little complicated with all the variables. So let me dumb it down a little bit by giving p a value. So let's say that p is equal to, let's say 5, right? And then your amount would end up being, it would be 5 plus 5 multiplied by 0.03 multiplied by, let's say for after 4 years, right? And then now in this case, I'm gonna make it really simple for you guys. So 5 is your p-value. That has to be included in your amount because it is your first value. Then you have 5 times 0.03. So I know I'm getting a little off topic by explaining simple interest, which I've already done before, but I mean I want to be sure that you guys get this concept. And then you have 5 times 0.03, right? So that gives you 5 times 0.03, and that'll give you 0.15. So then you have 0.15, right? And then finally you have 4, leave 4 there. So now it's plus 5, and actually we're giving equal signs. Okay, so this is what you have now. So now to 5, you're adding 0.015 4 times. So if you have, for example, 5 times 0. Sorry, not 5. If you have 4 times 0.15, it'll give you 0.6, right? So to 5, you're essentially adding on 0.6. And I'll show you why I'm doing all this in a second. But then, so essentially your final amount after 4 years becomes $5.60, right? Okay, so in this case, what we just did was a kind of a variation, I guess you could say, of an arithmetic sequence. Because if you, for example, took interest after 1 year, right? Which would the amount after 1 year, this 4 would become a 1, right? Which would mean that at this step you would have 5 plus just 0.03, right? And then your final answer would be $5.03. And then let's say if it was a 2, so I'm just gonna this is one set. Okay, not set, sorry, just a little, I'm just showing some work here. So let's say that it became the time that you did it for became 2. Then it would be 5 plus Oh, sorry. I made a mistake here. This is not. Yeah, I thought I made a mistake. It didn't make sense for it to be 0.03. Okay, so sorry. It's still 5 multiplied by that, right? So you still do 5 times 0.03, which gives you 0.15. Sorry, my bad. 0.15. So your value becomes $5.15. And then next you do let's say that your time is 2 years, so you put 2 here, right? And then that would mean that you're adding 0.15 twice, so that gives you 0.3. Sorry, 0.3, and then that makes your value $5.30, right? And then let's do the last one too. So we do all 4, and then you have you have 3. So let's say it's 3. That would make you're adding 0.15. How many times? You're adding it 3 times, right? So then 0.15 times 3 is 0.45. So you add 0.45, and then finally this will give you a value of $5.45, correct? So now the reason I did this was to show you guys a relationship between these things right now, and I'm about to do that. So now let's take all these values and write them down. So after 1 year, you had how much? You had 5, you had 5.15 after 1 year. And after 2 years, you had how much? You had 5, let me take that. You had 5.3, so $5.30. And after 2 years, you had $5.45. And after 3 years, you had $5.60. Now, you guys have probably picked up on the pattern already. And if you haven't, I'll explain it to you right now. So in this case, 1 is the second number. So let's relate this to an arithmetic sequence now. I mean, okay, so what do you add to 5.15 to get 5.3? You add 0.15, and then you add what? 0.15, and then you add what? You add 0.15. Now, a lot of you might be wondering, oh, the first term is 5.15, but it's actually not, because the first term is 5, because your original number was 5, right? It wasn't 5.15. 5.15 is the number that you got. So your original number is 5, and you can write 0.15 here too. So now let's look at this in terms of arithmetic sequence. What do we have now? We have an a value. A value is what? 5. We have a d value. D value is what? 0.15. So, okay, sorry about that little pause. Okay, so you have a value of 5 and d value of 0.15, right? So let's relate these values now, these values right here, to an arithmetic sequence. So to simple interest. So we knew from the beginning that our p value was what? P value was 5. So if a is equal to 5, then in this case p is also equal to 5, right? And then our interest was how much? Our interest was 3%, right? But then in this case, 3% is not the d value. Why? Because you're not adding 3%, you're adding 3% of 5 each time, right? So 3% of 5 is 0.03 times 5, sorry, times 5 is equal to your d value, because the difference the constant that you're adding is 3% of $5. So therefore your d value, the amount that you're adding, is going to be 0.15, as we see over here as well. We can get that from there, but I'm just doing it like this to show you guys. And then now we have a perfectly legitimate arithmetic sequence that we've just created out of a simple interest scenario. So from this we can see exactly how simple interest is, the formula for simple interest rather, is derived from arithmetic sequence, right? Because if you have an a value, your a value is your principal because it is the original amount, and then your d value is the percentage of the principal that you're adding, and your time value is your nth term. Oh, okay, so I should explain that as well because I didn't do that here. Okay, so if we go back to our arithmetic sequence, we have a plus d here, right? And then a plus 2d, and then plus 3d, and so we have to find a comparison for that too, right? So that would be, in this case, the amount of time that has gone by, right? So in this case, it's 5 plus 5 into 0.03 times 4, right? So if you calculate that, after 4 years, you have 5.6. So a little different between arithmetic sequence and simple interest is that if you have 4 here, right? Technically, in an arithmetic sequence, you would be doing n minus 1, right? Because in an arithmetic series, okay, so let me scroll down and explain this to you as well. This is really simple. This is nothing to worry about. So the formula for an arithmetic series is a plus n minus 1d, right? That's the formula for an arithmetic series. Tn, sorry, I should write that too. Tn is equal to that. Okay, so when you have n here, right? Technically in this, okay, so like I used it over here, right? I used Tn to find the amount. I use 4. So technically you would be using T5 here. And there's a legitimate reason for this. It's not like I'm making it up. If you have 5 minus 1, you get 4, right? But it's not just because the numbers work. There's a legitimate reason, and I'll tell you right now. If you have T5, you're calculating the term at the beginning. You're calculating your value at the beginning of 5. And in this case, you're calculating the amount of money at the end of 4. So the end of 4 is the beginning of 5. Therefore, it's the same thing. However, you write it a little differently. And that might be a little confusing, but it's actually really simple if you think about it. And so that is exactly how this. So time then essentially time becomes n minus 1, right? Because if you have n over here, n is equal to 5, right? Time is what? Time is n minus 1. Time is 4. Sorry. Yeah, 4. So see, because in simple interest you calculate at the end, and in this case you calculate at the beginning. So that's the only difference between that. So now I'm just going to derive the perfect formula. Not the perfect form. So I'm just going to derive the formula from arithmetic sequence now, finally, to show you quickly exactly how. Actually, I think we've pretty much done it. If we just write it down now, we can say that if the formula for an arithmetic series is Tn is equal to a plus n minus 1 d, and the formula, and we know that a is equal to p, and we know that n minus 1 is equal to t, and we know that d is equal to p times the percentage. So that's the only difference, pretty much. P times the percentage. So 0.0, or sorry, p times I over 100% to get rid of, I guess you can, no, you can just write r. P times r. And so now you have a formula. So let's sub it in. Let's see what happens. So Tn, and Tn is equal to amount, of course. Tn is equal to amount. Okay, so if you have amount here, so replace P with A, P plus, next what do you have? You have n minus 1. N minus 1, as we know to be T, and D we know to be PR. Why? Because it's the percentage of the principal that you're adding. That's the difference. That's the constant. So now we can simplify this, and we have A, and rearrange it a little bit. A is equal to PRT. And there we have just derived the simple interest formula from the arithmetic sequence formula. And as you can see, it's really, really simple. I mean, a lot of you, while working on these questions, have probably already noticed these relationships, and just never even thought about them because they're just so obvious. But then I'm just doing this now to show you and explain to you why, not explain why, but explain to you how it works, and in case any of you didn't pick up on that. And finally, oh, actually, yeah, that's pretty much it. I mean, if you, yeah, that's actually pretty much it. All right, thank you for. Okay, well, one more thing could be simple linear relationships, and I guess I should explain those. I should explain those to you too. I mean, it's pretty obvious why it's linear. It's because you're adding obviously you're adding the same number every time, right? So it has to be linear. But let's just look at that on a PowerPoint and on an Excel that I created here quickly, just to show you guys. Okay, so let's say okay, so I pretty much created an arithmetic series sequence here, and I did 1, 2, 3, 4, 5. And so for example, the initial value was 5, and then you add 0.15 each time. So 5.15, 5.3, 5.45, and 5.6, same thing we did over there. And then if you see here, you have a straight line. So look at that. Hold on, give me 1 second. So look at that, you have a straight line. Maybe I should put it between the points, that way it'll be more obvious. Okay, so between these you have it's a straight line. It's exactly linear. So that's a linear relationship right there. We can see from this graph that an arithmetic sequence is in a linear relationship. And what do we know from this? That if if an arithmetic sequence is a linear relationship, then that would mean that so if an arithmetic sequence, okay, that's not right arithmetic. Let's write an arithmetic sequence is represented by what? It's represented by a plus n minus 1d, right? And then so we know that a has this constant n minus 1d. Even though they're written variables, they do represent a constant. So this is added over. Oh, actually no, sorry. This is not a good way to represent it. So this is the constant. So we know that to a we're adding this n minus 1 over and over and over and over again, as many for however many d's we have, for however many oh, sorry, I got a little confused there. I made a mistake. Okay, sorry. This is the, okay, my bad about that. Don't, please bear with me. So you have this as the constant, and even though it's a variable, it represents a constant in an arithmetic sequence, and it's being added as many times as we want. And so since it's a constant, and we add it to a constant initial value, it'll increase by that constant rate. So it obviously represents an initial linear relationship. And so let's look at simple interest quickly. We have P plus PRT. Okay, so how does that relate? PR, we've already seen that PR represents what? It represents a constant. It represents D in this case, in a specific scenario. So PR is a constant. So if we're adding a constant, okay, so let's isolate this right now. So T is n minus 1. We know that. D is PR. So T and PR being multiplied, the only thing that changes is T. So if T is 1, then you add PR once. If T is 2, you add PR twice. If T is 3, you add PR 3 times. So PR plus PR plus PR 3 times. That's common sense. It's multiplication. So to P, if we're adding this common this common constant or this constant, then it's increasing by a constant ratio. It's increasing by 1 PR. It's increasing by 2 PR, by 3. Sorry about that pause. Okay, so like I said, if you're adding PR once to it, it goes up by 1 PR. If you add PR twice, it goes up by 2 PR. So let's say this is plus PR plus 2 PR plus 3 PR plus 4 PR. So as we can see, it's a linear relationship. So for both arithmetic sequences um, and for simple interest, we have linear relationships. So that explains to you exactly why these three concepts are related, and they're so simple. I mean, just by looking at them, you can understand exactly what is happening, how it's happening, and why it's happening. But you know, um, but I'm putting these videos up just so that for the few small percentage of you who did not catch on to this can also understand it. And thank you for watching my videos. I hope you, if you didn't already know, I hope you understand this topic now. I'll see you back next time when we discuss another mathematical concept, like always.